Among the hills of Italy and in the mountains of Arizona, priests in black cassocks observe the stars using some of the most sophisticated telescopes in the world. The Vatican Observatory is a scientific institution of the Church, which for centuries has been accused of opposing progress. Today, the Pope's astronomers study distant galaxies, search for exoplanets in habitable zones, and participate in conferences on astrobiology, the science of extraterrestrial life. "An alien is my brother," the director of the observatory declared in 2008, shocking the entire world. What is behind these words? Is the Vatican really preparing for contact with extraterrestrial intelligence? Or is there something more behind the powerful telescopes and loud statements? An attempt to reconcile ancient beliefs with the challenges of the space age. Today, we will look behind the dome of the Vatican Observatory and find out what priests are really looking for among the stars. If this video made you think about our place in the universe, be sure to subscribe to the channel and like it. Now, here's a question for discussion in the comments. Do you think that if humanity discovers intelligent extraterrestrial civilization tomorrow, it will strengthen religious faith or undermine it? Are the world's religions ready to accept the existence of other children of God? Share your opinion? Let's discuss this fascinating question together. Among the hills of Italy, far from the bustling streets of Rome, there is a place where priests do not pray but study the stars. The Vatican Observatory is one of the oldest astronomical institutions in the world, shrouded in mystery and intrigue. Why did the Church, which for centuries held a monopoly on truth, need to look through telescopes? And why is it that today, in the 21st century, astronomers in cassocks are actively involved in the search for extraterrestrial life? The history of the observatory dates back to the 16th century, when Pope Gregory III decided to reform the calendar. The Church faced a serious problem. The dates of religious holidays, especially Easter, were increasingly diverging from astronomical cycles. Precise science was needed to bring the celestial order into line with the ecclesiastical one. Thus began the story that would lead to the creation of an observatory capable of competing with the best scientific centers in the world. In 1578, the famous Tower of the Winds was built in the Vatican. It was erected not for defense, but for science. It was here, within these walls, that the Pope invited mathematicians and astronomers from the Jesuit order to make precise calculations of the movement of celestial bodies. The result of their work was the Gregorian calendar, which we still use today. But why did the Church not stop at this achievement and continue to develop astronomy? The 18th and 19th centuries were a time of scientific revolutions. The Catholic Church, remembering the case of Galileo, came under fire, accused of opposing scientific progress. Observatories were created and then closed depending on the political situation and the views of the current pontiff. In 1774, the Roman College Observatory opened, and 13 years later, the Vatican Observatory appeared in the Tower of the Winds under the leadership of monk Filippo Luigi Gilli. However, after his death in 1821, the observatory was closed. The dome of St. Peter's Basilica blocked most of the sky, making observations practically useless. The third attempt to create a permanent observatory came with the opening of the Capitoline Observatory, which operated from 1827 to 1870. But it too failed to become a long-term project. It seemed that Vatican astronomy was doomed to remain in the shadow of political upheavals and church disputes. However, everything changed at the end of the 19th century, when a pope who understood the importance of science for the authority of the Church came to power. On March 14, 1891, Pope Leo XIII issued a special rescript, Ut Mysticum, which officially revived the Vatican Observatory. This was not just a scientific project, but a political maneuver. The Church wanted to prove to the world that it was not an enemy of progress, but its ally. But was that the only goal? Or were there other, deeper reasons for studying space hidden behind the walls of the observatory? The Gregorian calendar, which is used throughout the world today, did not appear out of nowhere. Behind its creation lies a dramatic history of the Church's struggle with the chaos of time. By the 16th century, the accumulated error of the Julian calendar was already 10 days. The spring equinox, on which the calculation of Easter depended, had shifted so much that religious celebrations were losing touch with astronomical realities. For the Church, whose power was based on strict observance of sacred dates, this was a disaster. Pope Gregory XIII understood that solving this problem required mathematics, not theology. He turned to the Jesuits, an order that, since its founding in 1540, had combined religious zeal with scientific rigor. It was the Jesuits who created a network of educational institutions around the world, where they taught not only theology, but also the advanced science of their time. Among them was the mathematician Christopher Clavius, who worked at the Pontifical Gregorian University. Clavius headed the commission that undertook the revision of the calendar. The work required the most accurate astronomical observations. It was necessary to determine the length of the tropical year with maximum precision, calculate the movement of the sun relative to the stars, and understand the mechanisms of the precession of the Earth's axis. All this required not just one-time measurements, but systematic observations using the best instruments of the era. It was for these purposes that the Tower of the Winds was built in 1578. The results exceeded expectations. The new calendar, introduced in 1582, did not simply correct the accumulated error. It created a system that remains relevant more than 400 years later. But this success had unexpected consequences. The Church, which had created the calendar for religious purposes, suddenly found itself in possession of advanced astronomical knowledge. And this knowledge required further research. The Jesuits quickly realized the value of astronomy not only for ecclesiastical calculations, but also for missionary work. In China, India, and Japan, accurate predictions of eclipses and knowledge of planetary movements opened the doors to the courts of emperors. Astronomy became a tool for evangelism, but as science developed, questions arose that could no longer be answered by simple church explanations. What lies beyond the known cosmos? Are we alone in the universe? The calendar reform established a tradition that continues to this day. The Vatican continued to support astronomical research, understanding that science and faith could coexist. Moreover, they must coexist if the Church wants to remain relevant in a changing world. But were these the only motives? Or was the Church looking to the stars from the very beginning for answers to questions it did not speak aloud? The Tower of the Winds is not just a historical building, but a symbol of the union between faith and science. Its name comes from the frescoes decorating its walls, which depict the personifications of various winds. But the tower's true purpose was different. It became the Vatican's first scientific laboratory, a place where priests became scientists without ceasing to be servants of God. The tower's architecture reflected its dual nature. From the outside, it looked like a typical Renaissance building, elegant, proportional, decorated with art. But inside were instruments that were the pinnacle of technology for the 16th century. Specially designed openings in the walls allowed sunlight to penetrate inside at precisely defined moments. A meridian line was laid out on the floor of the tower, a kind of solar calendar that could be used to determine the moment of the spring equinox with hourly precision. Monk Filippo Luigi Gili, who headed the observatory in 1787, was a man of unusual destiny. Born in 1756, he devoted his life to serving two masters, God and science. During his time, astronomy was undergoing a revolution. Telescopes were becoming more powerful, new planets were being discovered, and catalogs of stars were being compiled. Gili understood that the Vatican could not remain on the sidelines of these discoveries. Under his leadership, systematic observations were carried out in the Tower of the Winds. The positions of the planets were recorded, sunspots were tracked, and the movements of comets were studied. This data was not only of scientific value, it served as proof that the Church was not afraid of the truth, even if that truth challenged traditional beliefs. However, Gili's work encountered a serious obstacle: the geographical location of the observatory. The dome of St. Peter's Basilica, Michelangelo's greatest architectural masterpiece, blocked a significant part of the southern sky. It was in this area that many important astronomical objects were located. It was practically impossible to observe them from the tower. Added to this were the problems of a growing city: smoke from chimneys, light pollution from torches and candles, vibrations from construction work. The tower, ideal for calendar calculations, proved unsuitable for serious astronomy. After Gili's death in 1821, the observatory was closed. But the idea did not die. The instruments were transferred to the observatory of the Roman College, where the tradition of astronomical research continued. The Tower of the Winds became a monument, a reminder that the Church once dared to look at the sky not only through the eyes of faith, but also through the eyes of science. But the question remained open. Why did the Church so stubbornly return to astronomy, despite all the obstacles? Among all the Jesuit astronomers of the 19th century, the name of Angelo Secchi occupies a special place. This man is called the father of astrophysics, an unofficial but well-deserved title. Secchi did what no one before him had done. He didn't just look at the stars, he looked into their souls, breaking down their light into its components. Angelo Francesco Ignazio Baldassare Secchi was born on June 28, 1818, in Reggio, Lombardy. From 1833, he was a member of the Jesuit order, dedicating his life to service through science. He was educated at the Roman College, where he studied mathematics and physics. At first, he taught ancient languages, but gradually his interest in the sky took precedence over everything else. Fate forced Secchi to change his place of residence several times. In 1848, when the Jesuits were expelled from Rome during the revolutionary unrest, he went to England, where he taught at Stonyhurst College. He then moved to America, to Georgetown University near Washington. It was there, far from his homeland, that he finally devoted himself to astronomy. In 1849, thanks to his scientific reputation, Secchi was able to return to Rome and took up the post of director of the Roman College Observatory. Secchi completely reorganized the observatory, equipping it with the best instruments of his time. But his real breakthrough was the use of spectroscopy, a method of studying light broken down into its components. Before Secchi, astronomers could only determine the position and brightness of stars. He learned to read their chemical composition, temperature, and speed of movement. Between 1863 and 1868, Secchi studied the spectra of about 4,000 stars. His main achievement was the first classification of stars by their spectra in history. Secchi divided stars into several classes, depending on the nature of their spectral lines. Although this system was later refined, it laid the foundation for modern astronomy. For the first time, it became possible not only to observe stars, but also to understand their nature. Secchi was the first to experimentally prove that the Sun is an ordinary star, not a unique object. Secchi's work ushered in a new era. It turned out that spectral analysis could be used to measure the temperature of distant objects, determine their age, and understand the processes taking place in their interiors. The method made it possible to study galaxies at unimaginable distances, find the magnetic fields of stars, and recognize black holes. A priest in a cassock made a revolution, the consequences of which we still feel today. But why did a Jesuit, who had taken a vow to serve God, study the material nature of the universe so persistently? And did he find something more than just physical laws in the stars? By the end of the 19th century, the Catholic Church was in a difficult position. The unification of Italy had deprived the Pope of secular power. The conflict with science after the Galileo affair remained an unhealed wound, and the secularization of society was gaining momentum. In these circumstances, Pope Leo XIII, elected in 1878, understood that the Church had to prove that it was not afraid of knowledge. Vincenzo Gioacchino, Raffaele Luigi Pecci, who took the name Leo XIII, was an educated and pragmatic man. He saw that accusations of obscurantism were doing more harm to the Church than any scientific discoveries. In 1880, he opened the Vatican secret archives, which had previously been virtually closed to researchers, to scholars. It was a gesture of goodwill, showing that the Church had nothing to hide. But archives are the past. Something more significant was needed for the future. On March 14, 1891, Pope Leo XIII issued the rescript Ut Mysticam, which officially revived the Vatican Observatory. The document was carefully drafted, with every word weighed. The goal was clearly stated: to refute the constant accusations that the Church is opposed to scientific progress. The observatory was to become living proof that faith and reason are not enemies. The new observatory was located in a palace on a hill behind St. Peter's Basilica. The selection of personnel was strict. People who were able to combine a religious vocation with scientific qualifications were required. The Jesuits, with their tradition of education and research, were once again at the forefront. The observatory quickly became involved in international cooperation. One of its first projects was participation in the ambitious Carte du Ciel plan, an attempt to create a complete map of the starry sky with the involvement of more than a dozen observatories around the world. It was the first major international scientific project in history, and the Vatican became a full participant. Priests worked side by side with atheists and Protestants, united by a common goal of knowledge. Politics and religion took a back seat to the grandeur of space. But success brought new challenges. Rome was growing, and light and air pollution were increasing. By the 1930s, it became clear that it was no longer possible to observe the stars from the center of the capital. The decision was made quickly. On September 29, 1935, a new observatory was officially opened in Castel Gandolfo, the summer residence of the popes, 25 kilometers from Rome. The observatory was equipped with the latest equipment, the best telescopes of its time. But the world was changing faster than expected. Soon, World War II broke out, followed by the Cold War. In this new world, questions about life beyond Earth were no longer abstract philosophy. They became a reality that had to be prepared for. Castel Gandolfo is a place of astonishing beauty. The town is located in the Alban Hills, overlooking a volcanic lake formed thousands of years ago. Since the 16th century, this place has served as the summer residence of the Roman popes, who sought refuge here from the exhausting summer heat. But in 1935, the quiet country palace was transformed into a cutting-edge scientific center. The observatory's relocation was not just a change of address, it was the dawn of a new era. Far from the noise and lights of the city, the conditions for observation became ideal. Clean air, dark night skies, and no vibrations, everything contributed to accurate measurements. Pope Pius XIII personally supervised the construction of new buildings and the installation of equipment. The observatory received modern telescopes capable of photographing faint objects and conducting spectral research. The Jesuits, who had managed the observatory since the 1930s, turned it into a place where monastic discipline was combined with scientific rigor. The day began with prayer, continued with calculations and observations, and ended with prayer again. For them, there was no contradiction between serving God and studying His creation. On the contrary, each discovery was perceived as a step closer to understanding the divine plan. A rich astronomical library and archives were created in Castel Gandolfo. The collection included rare manuscripts, observations made as far back as the Middle Ages, and the first photographic plates of the starry sky. It was not just a scientific institute, but a repository of memories of humanity's centuries-long attempts to understand the cosmos. Scientists from all over the world came here to work with unique materials. However, time did not stand still. By the 1970s, the population of the region had grown so much that light pollution became a problem even in Castel Gandolfo. The lights of Rome's sprawling suburbs turned the night sky into an orange haze. Observing faint objects became increasingly difficult. The Jesuits realized that they needed to find a new location, even further away from civilization. In 1981, a bold decision was made to establish a branch of the observatory overseas, in the state of Arizona, USA. The mountains in the southeast of the state were renowned for their ideal conditions for astronomical observations. The altitude, dry air, and minimal cloud cover made it the perfect location for a telescope. Construction began, which would result in the creation of one of the most modern instruments in the Vatican's arsenal. But why did a small state with no space program need a world-class telescope? What exactly were astronomers looking for in the black void between the stars? Mount Graham in southeastern Arizona rises 3,178 meters above sea level. It is a sacred place for the Apache Indians, but for astronomers, it is one of the best spots in the continental United States for observing the sky. It was here, far from cities and industry, that a telescope began operating in 1993 that would become the Eye of the Vatican in space. The Vatican Advanced Technology Telescope, known by the acronym VATT, is not just an astronomical instrument. It is a statement of intent. The main mirror, with a diameter of 1 meter 80 centimeters, was manufactured using unique technology at the University of Arizona's Mirror Laboratory. It is a honeycomb structure made of borosilicate glass, cast using a centrifugation method, a pioneering technique that was later used to create mirrors with a diameter of up to 8.5 meters. The mirror has a focal ratio of 1:1, which means that the focus of the telescope is at a distance equal to the diameter of the mirror. This deep curvature has made it possible to create an extremely compact design. The telescope is 3 times smaller than traditional instruments of similar power. The secondary mirror, with a diameter of 38 centimeters, is made of ceradur, a material with zero thermal expansion. Its position is controlled with an accuracy of 1/10 of a micron, the precision required for such a fast optical system. The building that houses the telescope was designed with thermodynamics in mind. The dome is thermally insulated from the observer's living quarters so that heat does not create air turbulence that distorts images. Air from the dome is vented on the north, leeward side. Every detail has been thought out to achieve the highest quality observations. VATT has become part of the Mount Graham International Observatory, where several telescopes from different organizations operate. The telescope is operated by the Vatican Observatory Research Group in collaboration with the University of Arizona. Agreements have been signed with other educational institutions, such as the University of Notre Dame in Indiana, which receives 20 nights of observation per year. In 2024, the telescope was upgraded with the installation of the Dawn robotic system, which allows celestial objects to be tracked for 20 minutes with perfect accuracy without manual control. With the help of VATT, Vatican astronomers study the formation and evolution of galaxies, explore exoplanets, planets around other stars, and analyze the composition of asteroids and comets. Hundreds of scientific articles are published in leading international journals. But among these studies, one question that has preoccupied humanity since ancient times occupies a special place. Is there life beyond Earth? And if so, what does this mean for religion, for understanding our place in the universe? Why do priests study the stars? This question seems paradoxical only at first glance. For the Jesuits, an order founded by Ignatius Loyola in 1540, science has never been at odds with faith. On the contrary, it was its continuation. The founder of the order spent hours on his balcony contemplating the night sky and found spiritual solace in it. His call to find God in everything became the motto of Jesuit science. Jesuit spirituality is incarnational. It affirms that God is present in the material world, works through it, and labors for us in His creation. If this is so, then the study of nature becomes a way of knowing the Creator. Astronomy becomes an act of prayer, a way to come closer to understanding the divine plan. The results of scientific research become a cause for admiration and gratitude. This philosophy led to the Jesuits making an enormous contribution to the development of science. About 60 craters on the Moon and asteroids are named after Jesuit scientists. Christopher Clavius, creator of the Gregorian calendar. Athanasius Kircher, a 17th-century encyclopedist. Roger Boscovich, who developed the theory of atomism. Angelo Secchi, founder of astrophysics. The list goes on and on. These people saw no conflict between the cassock and the telescope, between the prayer book and the mathematical treatise. Since the 1930s, the Society of Jesus has taken responsibility for forming and staffing the Vatican Observatory. Most of the staff are researchers engaged in astronomy and dedicated to understanding the universe. There are also Jesuits involved in administration and fundraising, without which scientific work would be impossible. Some specialize in the history of science and popularization, making the work of the observatory known to the general public. The requirements for candidates are strict. A love of science, the ability to collaborate with colleagues, thoughtfulness, and prudence are essential, as each person represents the Church in the scientific world. In 2025, Father Richard D'Souza became the director of the observatory, replacing Brother Guy Consolmagno, who had headed it since 2015. Consolmagno, author of 13 books, wrote in one of his latest works, A Jesuit's Guide to the Stars, "If we believe that God created this universe, and if we believe that God loved it so much that He sent His Son to become part of it, then science becomes an act of drawing closer to the Creator. In this sense, it becomes an act of prayer." 80% of the Jesuit astronomers' work is ordinary science, research, publications, conferences, meetings with colleagues, but the remaining 20% is a mission, to be a visible sign that the Church is at the forefront of knowledge, that it is not afraid of the truth. But what truth lies hidden in the depths of space, where the Vatican's telescopes are directed? May 2008 was a turning point in the Vatican's public stance on extraterrestrial life. The director of the Vatican Observatory, Jesuit priest José Gabriel Funes, gave an interview to the Vatican's official newspaper, L'Osservatore Romano, which instantly spread around the world. The article had a provocative title, "The Alien is My Brother." Funes, an Argentine astronomer who headed the observatory, made several statements that were revolutionary for a religious figure. He argued that belief in the existence of extraterrestrials does not contradict the Bible. Moreover, denying the possibility of extraterrestrial life means limiting the omnipotence of God. If the Creator created an infinite universe, why should life exist on only one planet? How can we deny that life could have originated somewhere else besides Earth? Funes asked. We consider earthly beings to be our brothers and sisters, so why not assume that there are alien brothers? If they exist, then they too are part of the universe created by God. These words came as a surprise, especially to those who remembered the story of Giordano Bruno, who was burned at the stake in 1600 for, among other things, claiming that there were many inhabited worlds. But Funes went even further. He suggested that some alien civilizations, if they exist, may be free from original sin. Perhaps they remained in complete harmony with the Creator and do not need redemption. This idea raised complex theological questions. If Christ died for the sins of humanity, does this salvation extend to other intelligent beings? Or does each civilization have its own history of relationship with God? The reaction of the world media was stormy. Headlines screamed, "The Vatican has recognized the existence of aliens," although Funes was only talking about the possibility. Representatives of other faiths reacted with restraint. The Secretary for Inter-Christian Relations of the Moscow Patriarchate called Funes' statements the private opinion of an individual, emphasizing that this issue is not important for the Orthodox Church, as it does not concern its main mission, the salvation of the human soul. But was it really a private opinion? Funes was the director of an official Vatican scientific organization. His article was published in a Vatican newspaper. Obviously, the position had been agreed upon with the highest church circles. The Vatican was preparing for a possibility that until recently seemed like science fiction, but with each passing year was becoming more and more real. The discovery of exoplanets, planets orbiting other stars, was proceeding at an explosive pace. The question was no longer, does life exist in space, but when will we discover it? And the Church wanted to be ready for that moment. In November 2009, an event took place within the walls of the Vatican that would have seemed incredible not long ago. The Vatican Observatory, in collaboration with the Pontifical Academy of Sciences, held a week-long scientific conference on astrobiology, the science of possible life in the universe. More than 30 scientists, including astronomers, biologists, geologists, and religious thinkers, gathered to discuss the origin of life and the prospects for its discovery beyond Earth. These questions have many philosophical and theological implications, said Father José Funes as he opened the conference. The program was divided into 8 segments. The first ones were devoted to life on Earth, its origin, the evolution of Earth's habitability, and the relationship between the environment and the genome. Then, methods for detecting life in other worlds, strategies for searching for exoplanets, their formation and properties were discussed. The culmination was segments on the possibility of intelligence elsewhere in the universe and so-called shadow life, life forms with alternative biochemistry that may exist right here on Earth but remain undetected. Among the participants were luminaries of science. Chris Impey from the University of Arizona, an expert on exoplanets. Jonathan Lunin from the University of Rome, who studies the moons of giant planets as potential habitats for life. Simon Conway Morris from Cambridge, an expert in evolutionary biology. The presence of such scientists demonstrated the seriousness of the Vatican's approach. This was not a propaganda stunt, but a genuine scientific forum. The discussions were at the most advanced level. They talked about biomarkers, traces of life that can be found in the atmospheres of distant planets. They discussed methane and oxygen as potential indicators of biological activity. They analyzed data on planets in the habitable zone, the area around a star where the temperature allows liquid water to exist. Extremophiles, Earth organisms that live in incredible conditions, showing how resilient life can be, were also considered. Of particular interest was the report on the Kepler mission, a space telescope launched by NASA in 2009. By the time of the conference, the telescope had already transmitted its first data, showing that planets around other stars are not a rarity, but the norm. Scientists discussed methods of transit photometry, the detection of planets by the dimming of a star's brightness when a planet passes in front of its disk. Each such passage provided information about the size of the planet, its orbit, and the possible composition of its atmosphere. But the most heated discussions revolved around philosophical questions. If we discover the simplest life, bacteria on Mars or in the ocean of the moon Europa, how will this change our understanding of the uniqueness of life on Earth? If we find intelligent civilization, what will that mean for religion? The Vatican has shown a willingness to discuss these issues openly, without hiding behind dogma. The conference ended on an optimistic note. Scientists and theologians agreed that the search for life in the universe does not threaten faith, but enriches it. Each discovery broadens our understanding of creation, but the conference also showed that the Vatican is not just observing scientific progress, it is actively participating in it. Astronomers in cassocks are not lagging behind their secular colleagues. They ask the same questions, use the same methods, and strive for the same discoveries. The only difference is that for them, each answer reveals a new facet of divine design. By 2025, humanity had discovered more than 5,000 exoplanets, planets orbiting other stars. This is a revolution comparable to Copernicus's discovery. We now know that our solar system is not unique. Planets are everywhere. And if planets are everywhere, why shouldn't life be just as widespread? This is precisely the question that astronomers at the Vatican Observatory are working on. The search for exoplanets is an extremely difficult task. Planets do not shine on their own. They only reflect the light of stars. Detecting a planet against the background of a bright star is like seeing a firefly next to a spotlight thousands of kilometers away. Scientists use indirect methods. The radial velocity method detects the wobble of a star under the gravitational influence of a planet. The transit method registers a tiny dimming of the star's brightness when the planet passes in front of its disk. Vatican astronomers are actively involved in this research. Using the VATT telescope, they conduct spectral observations of candidate stars, refine the parameters of known exoplanets, and study their atmospheres. Of particular interest are planets in the habitable zone, areas where the temperature allows water to exist in liquid form. Liquid water is considered a necessary condition for life as we know it. But it is not enough to simply find a planet in the habitable zone. Biosignatures are needed, signs of life that can be detected remotely. The main biosignature is oxygen. On Earth, almost all of the oxygen in the atmosphere is produced by living organisms, first by cyanobacteria, then by plants. Oxygen is chemically active and quickly combines with other elements. If oxygen is constantly present in a planet's atmosphere, it means that something is continuously producing it, and that something could be life. Other potential biomarkers include methane in combination with oxygen, ozone, water vapor in certain ratios, and even chlorophyll, which can be detected by the spectral fingerprint of reflected light. Modern telescopes, such as the James Webb Space Telescope, launched in 2021, are capable of analyzing the composition of exoplanet atmospheres. Each spectrum is a chemical passport to a distant world. Vatican scientists are participating in international programs to analyze data from such telescopes. They are developing algorithms for recognizing biosignatures, modeling the evolution of planetary atmospheres, and calculating the probability of life emerging under various conditions. This is not abstract science. It is preparation for a possible discovery that will change everything. The discovery that we are not alone. But there is another level of search. Intelligent life. Civilizations capable of technology, possibly space travel or radio communication. The SETI program, Search for Extraterrestrial Intelligence, searches for artificial radio signals from space. The Vatican does not participate directly in SETI, but it monitors the results. Because if intelligent aliens exist, theological questions will become even more complex and interesting. What would happen if tomorrow we received confirmation of the existence of intelligent extraterrestrial civilizations? How would this affect religion and humanity's understanding of its place in the universe? These questions concern not only science fiction writers, but also serious theologians. And the Vatican was one of the first to begin preparing answers. The central problem is the doctrine of the Incarnation. Christianity teaches that God became man in the person of Jesus Christ to atone for the sins of humanity. The crucifixion and resurrection are unique events that took place on a specific planet at a specific moment in time. But what if there are other intelligent beings on other planets? Do they need redemption? Did God incarnate for them too? Vatican theologians offer several approaches. The first is the universality of redemption. Christ's sacrifice has cosmic significance. It applies to the entire universe, to all intelligent beings, wherever they may be. The second approach, proposed by Funes, is the possibility of intelligent beings existing without original sin. If an alien civilization has not fallen, it does not need salvation. The third approach is the multiplicity of incarnations. God could have incarnated in different forms on different planets. This third idea is not new. As early as the 13th century, Thomas Aquinas suggested that God could incarnate not only as a human being. In the 20th century, Catholic theologian Karl Rahner wrote about the possibility of multiple incarnations. The universe is so vast that it seems strange to limit God's action to one planet. But these ideas remain theological reflections rather than official doctrine. Another question is how to treat aliens morally. Are they neighbors in the evangelical sense? Brother Guy Consolmagno, former director of the observatory, answered unequivocally, yes. If they are intelligent beings created by God, then they are our brothers and sisters, regardless of their biological origin. The commandment, "Love your neighbor," should extend to all intelligent beings in the universe. This raises practical questions. How should we conduct missionary work among extraterrestrials? Is it even necessary? Could they have their own revelations from God? Their own sacred writings? Consul Magno said half-jokingly that he would be happy to baptize an extraterrestrial if they asked. But he added seriously that it is more important to respect their autonomy and dignity. The Vatican shows a willingness to engage in open dialogue. In 2014, the Observatory, together with the Lunar and Planetary Institute and NASA, held a conference entitled The Search for Life Beyond the Solar System. Not only scientific but also philosophical aspects were discussed. The Church does not shy away from difficult questions. It embraces them. Because faith that fears knowledge is weak faith. True faith must be ready for any truth, even that somewhere among the stars there are other children of God. Rumors have always swirled around the Vatican. Secret archives, closed to prying eyes, forbidden knowledge, guarded for centuries. And, of course, a popular topic among conspiracy theorists is whether the Vatican is hiding information about contacts with extraterrestrials. Is the Church hiding evidence of visits to Earth by extraterrestrial civilizations? These theories gained new momentum in 2024, when ufology researchers claimed that documents about UFOs may be stored in the Vatican Apostolic Archives. Diana Walsh-Pasulka, a professor of philosophy of religion who studies the relationship between religion and the UFO phenomenon, suggested that the archives may contain medieval accounts of unusual celestial phenomena, interpreted as religious visions. Indeed, history is full of records of strange objects in the sky. Medieval chronicles describe fiery shields flying over cities, heavenly armies fighting in the clouds, glowing crosses and balls. These phenomena were often associated with divine omens, harbingers of wars, epidemics, and the death of monarchs. But could some of them have been observations of real anomalous objects? The Vatican Archives, officially renamed in 2019 from Secret to Apostolic, contain 85 kilometers of shelves with documents accumulated over 12 centuries. Access to the archives is restricted. Researchers can study materials older than 75 years, and only after obtaining permission. This fuels rumors of information being concealed. However, the Vatican's official position is unequivocal. There are no documents about contacts with extraterrestrials. In 2024, observatory astronomer Chris Corbali categorically rejected claims that the archives contain materials on UFOs. He explained that many medieval descriptions of celestial signs have simple astronomical explanations: comets, meteors, auroras, atmospheric optical effects. Moreover, the Vatican openly states that if there were evidence of extraterrestrial intelligence, the Church would not hide it. On the contrary, such a discovery would be welcomed as an expansion of our understanding of divine creation. Why hide something that enriches faith? The Vatican's secrets are related to diplomacy, internal church affairs, and the personal documents of popes, but not to aliens. Nevertheless, conspiracy theories persist. The VATT telescope is sometimes mistakenly referred to as Lucifer, attributing sinister purposes to it. In fact, a telescope with that name does exist, but it is a separate instrument located on the same Mount Graham. The acronym LUCIFER stood for Large Binocular Telescope Near Infrared Utility, with camera and integral field unit for extragalactic research. A binocular infrared telescope for studying galaxies. It belongs to a German-Italian consortium, not the Vatican, and was later renamed LUCI. The confusion between the two telescopes gave rise to myths that the Vatican was searching for demons in space or preparing for the coming of the Antichrist. The reality is more prosaic. Astronomers are studying galaxies, stars, and exoplanets using scientific methods. No secret knowledge, no contacts, yet. But if they happen, the world will be among the first to know. The search for extraterrestrial life is a high-profile topic that attracts public attention. But most of the work of the Vatican Observatory is devoted to fundamental astronomy, research that expands our understanding of the universe regardless of the question of life. And here, the Vatican's astronomers have made impressive achievements. One of the main areas of focus is the study of the formation and evolution of galaxies. Using the VATT telescope and data from space observatories, Vatican scientists analyze light from galaxies billions of light-years away. This light has traveled so long that it shows us galaxies in their youth, 1 billion or 2 years after the Big Bang. By comparing young and old galaxies, we can understand how they change over time. Of particular interest are active galactic nuclei, regions at the center of some galaxies where a supermassive black hole absorbs matter, emitting enormous amounts of energy. These objects, called quasars and Seyfert galaxies, are so bright that they are visible at the edge of the observable universe. Astronomers at the observatory study the spectra of these objects, trying to understand the mechanisms of accretion of matter onto black holes and the influence of this process on the evolution of galaxies. Another area of interest is variable stars. These are stars whose brightness changes over time for various reasons: pulsations, eclipses in binary systems, flares. Some types of variables, such as Cepheids, are used as standard candles to measure distances in the universe. Vatican astronomers conduct systematic observations of variable stars, refining the period luminosity relationships that are critical to cosmology. Asteroids and comets are another area of research. These small bodies in the solar system are remnants of planet formation, time capsules that preserve information about the early stages of our system's history. Spectroscopic observations of asteroids allow us to determine their chemical composition and identify different classes based on mineralogy. Some asteroids are rich in carbon and water. Perhaps it was these bodies that brought water and organic matter to the young Earth. Dark matter and dark energy are the greatest mysteries of modern cosmology. We know that visible matter, stars, gas, planets, accounts for only about 5% of the mass energy of the universe. 27% is dark matter, an invisible substance that manifests itself only through gravity. 68% is dark energy, a mysterious force that accelerates the expansion of the universe. Vatican astronomers participate in international programs to study these phenomena. The work of the observatory's astronomers is published in leading scientific journals such as the Astrophysical Journal, Astronomy and Astrophysics, and monthly notices of the Royal Astronomical Society. They are cited by colleagues around the world. They participate in international conferences and collaborate with major observatories. This is full-fledged science at the forefront of knowledge, and for them, each discovery is not just a fact, but another stroke in the portrait of creation, another reason to revere the grandeur of the cosmos. So, what is the Vatican really hiding behind the domes of its observatories? The answer is both simple and complex. Simple because there are no secret contacts with aliens, no hidden revelations, no conspiracies. Complex because the true purpose of Vatican astronomy is deeper than it seems at first glance. The Church does not study space out of pure scientific curiosity. For Jesuit astronomers, the telescope is an instrument of theology. Every galaxy, every star, every planet is a word in the book of creation. By reading this book, they come closer to understanding the author. Science becomes a form of prayer, research an act of worship. But there is also a practical side. The Church remembers the Galileo affair, a mistake that for centuries made it a symbol of opposition to science. The Vatican Observatory is atonement for that mistake, proof that faith and reason can work together. The Church's presence at the forefront of astronomical research tells the world that we are not afraid of the truth, whatever it may be. The question of extraterrestrial life occupies a special place. The Vatican is preparing for a discovery that could shake the foundations of human self-understanding. If we discover life, simple or intelligent, it will raise the most difficult theological questions. It is better to start thinking about the answers in advance than to be caught off guard. Conferences, publications, statements such as, "The alien is my brother," all this is preparation of public opinion. Perhaps the most interesting thing is the convergence of science and religion on a cosmological scale. Modern astronomy has revealed a universe of unimaginable size and age. Hundreds of billions of galaxies, each with hundreds of billions of stars. A history spanning nearly 14 billion years. The laws of physics are tuned with such precision that the slightest deviation would make the existence of atoms, stars, and life impossible. For many scientists, this fine-tuning suggests a design. Vatican astronomers do not claim that science proves the existence of God, but they do claim that science is compatible with belief in a creator. Moreover, the grandeur and beauty of the universe revealed by science make faith deeper and richer. Medieval peasants believed in a sky made up of several crystal spheres. Modern believers can contemplate trillions of galaxies, black holes, neutron stars, quantum fields, and find even more reasons for reverence in this. What is the Vatican hiding? Nothing but the desire to understand. To understand how the world works. To understand whether we are alone. To understand what place humanity occupies in the grand cosmic spectacle. And if one day the telescopes on Mount Graham or in Castel Gandolfo detect a signal from a distant civilization, the priest astronomers will be ready. Ready to meet their brothers in reason. Ready to expand their understanding of divine creation. Ready for a new chapter in the history of humanity's relationship with the cosmos and with God.